grade 8. My name is Mrs. Lian. I miss you so much, okay? Let's start our lesson, our first lesson in grade 8. Please be attention and focus with me. Finally, you have to study hard at home each lesson that you listen and watch, okay? Okay, let's start with our lesson. It's very fantastic. It's talking about matter. When I ask you grade 8, remind me from grade 5, 6, and 7, what is matter? What is matter? It's everything around us which has mass and occupies a space. So we can say, you are a matter, okay? Air is a matter, yes. The screen is a matter. I can say this ball is a matter. Why? Because it has a mass and occupies a space. I mean, it has a volume. So when I put this ball on this bench, what's happening? It takes a space, so it has a volume. It occupies a space. And also when I put this ball on a balance, it has a specific mass. So this ball is a matter, right? Okay, remind me also, how many states of matter? There are 3 states. What are these? Solids, liquids, and gases, of course. Okay, but in this year, we will take the 4th state of matter, inshallah, in the next lesson. So we have 3 states of matter in general. When we talk about the states of matter, we have to talk about their properties. What are the properties of matter? When we talk about the matter, we can describe its shape, its volume, right? Its behavior, the effect of temperature and the pressure, right? Okay, but in this year we will talk about the 3 new expressions, which are fluidity. Say after me, fluidity. Compressibility. Third one, diffusibility. To understand these new expressions, you have to do with me these experiments at home and watch which thing I will use. And please bring with me a bottle of water. I need an empty cup. Also, I can use sand and an empty cup. Let's start from water. Tell me, when I pour water by this way, it's easy, right? Water can be poured easily. Okay, it has high fluidity. Here, can I pour sand or do you love Nescafe? Okay, can I pour it easily? Not easily, not as water, right? Why? Water is a fluid. Sorry? Water is a fluid. I mean, this liquid takes the shape of its container. Its particles can take the shape of its container, so water or fluids have indefinite shapes. While in the sand case, we can see the particles of sand or Nescafe take its own shape. It doesn't take the shape of its container. So solid particles have definite shapes, while liquids or fluids take the shape of their containers. So which one has higher fluidity? I can say, yes, liquids or fluids have higher fluidity than the fluidity of solids. So I can say solids cannot be flood easily against liquids and gases. Oh, what about gases? As you see in this experiment, when I put more than 1 cube in the cup, can these cubes take the shape of its container? No. As you see, each cube here has its own shape. They have definite shapes, as you see. They don't take the shape of its container. So solids cannot flow. Solids cannot flow. Why? Because they have definite shapes that don't take the shape of their containers. So when I ask you, give reason. Gases and liquids have the ability to flow, have high fluidity. Why? Because the molecules of gases, also the molecules of liquids or fluids, take the shape of their containers. Take the shape of their containers. They can flow. This is the give reason question which I asked you now. Now we can determine what are fluids. What are fluids? Fluids, they are substance which has the ability to flow easily, and take the shape of their containers. As you see now, the same liquid with the same volume takes the shape of its container. Okay. Also, gases, each gas or any gas can take the shape of its container, as we can see the balloons, different shapes of balloons and different shapes of balls. Okay, what is fluidity? Fluidity means the ability of matter to flow easily, or the ability of fluids to flow easily. Okay, do you think what is the effect of viscosity? What is the viscosity? I mean the heaviness of matter. I am talking about the honey. Do you know honey? Honey has higher viscosity than the viscosity of water. So which one is easier? To pour water in a cup, as I did now, okay? Or to pour an amount of honey in the same cup. Honey has greater viscosity than the viscosity of what? Of water. So which one has greater fluidity? Of course, water. Water has greater fluidity than the fluidity of honey, while vice versa, honey has greater viscosity than that in water. So there is an inverse relation between fluidity and viscosity. Okay, by increasing the viscosity, the fluidity decreasing, and vice versa. By increasing the fluidity, viscosity decreases. Okay. So what is viscosity? It's a physical property that expresses the extent to which liquids resist flow. Which one resists the flowing or pouring of liquid? It's what? It's honey. It's honey which has greater viscosity than the viscosity of water. But which one has greater fluidity? Of course, water, which has least viscosity. Yes. Can you see? Honey has high viscosity, so it has the least fluidity. Water is vice versa, has greater fluidity and smaller viscosity. It can be flowed easily, can be poured easily. As you see, you can do this experiment at home to make sure that honey has greater viscosity than the viscosity of water. Okay, now it's time of compressibility. We understood what is fluidity. Now we can understand what is compressibility. Okay, to understand what is compressibility, I need three things as these. Okay, first one contains sand inside. Okay, they are particles of sand inside. The second one contains water. The third one is empty. I mean contains air. Contains air inside. So we have three things. Our experiment to understand what is compressibility. I have the first one has or contains sand inside. Second one contains water. Third one is empty, contains air inside. Let's do our experiment to show what is the relationship between the type of matter and its volume. When I talked about fluidity, I talked about its shape, right? I said solids have definite shapes while liquids and gases have no definite shapes or have indefinite shapes, right? When I talk about compressibility, I am talking about its volume. I'm talking about matter's volume. So when I compress or press on the particles of sand, as you see, does the volume of particle here change it? Does it change from 9 milli to 8 to 6 to any milli here? Is it decreasing? No. Its volume doesn't decrease. Why? Because solids have definite volumes. I can't compress them. Do you know why? The spaces between the particles of solids are very small, little spaces. So they are already together. They have not spaces between its particles to compress them easily. So I can't compress them again. There are no spaces between its particles. There are no spaces between its particles. So it's incompressible matter. It's what? Incompressible matter. Solid matter is incompressible matter that I can't compress or press on its particles easily. Why? Because we have tiny spaces between of them. What about water? Let's watch. The particles of water here also have similar volume. The volume of water or fluids don't change as volumes of fluids don't change as you see. So liquids also are incompressible that I can't compress their particles easily. As you see, also liquids have what? Have, yes, definite volumes, have definite volumes. Let's do the same experiment but with gases. Can I compress the molecules of gas inside this ring easily? As you see, I can change its volume. So, yeah, the molecules of gases can be compressed easily. I can say they are compressible molecules. So, gases are compressible. I mean, I can press on them easily and they change the volume of gas. And it changes the volume of gas. So, gases only have indefinite volumes, while solids and liquids have definite volumes, as you see. So what do we mean when we say that gases are compressible? When I ask you, give reason. Gases are compressible matters. Why? You can answer. That's their volume decreases as the pressure on them increases. So now I can define what is compressibility. What is compressibility? It is the possibility to decrease the volume of gases, okay, by increasing the pressure. As you saw, and you can see again, by increasing the pressure, when I press again on the molecules, the volume decreases, as you see, so it can be compressed easily. Again, what is compressibility? It is the possibility to reduce the volume of only gases. I didn't say solids or liquids. Why? Because only gases that can be compressed. So when I talk about compressibility, I mean gases only. Okay? Okay. The last one, the third property is diffusibility. What is diffusion or diffusibility. To understand what is diffusibility or diffusion, you can do this experiment. I have a bottle of perfume, okay? When I press, you can do the experiment at home like me. When I press on this button of perfume, after some seconds, what will happen? Everyone in the place or in the class here can smell this odor easily. Why? What happened here? As you know, uh, this perfume, like a gas under pressure, okay, when I press on the button, the molecules of gas move from the higher concentration, okay, to the lower concentration and spread everywhere. Yes. So the molecules of gases can be spread easily, so we can smell each other around us, even in the street, even in the second class. I can smell it because molecules of gas can be spread easily. Gases have high diffusion. Gases have high diffusion that can spread everywhere. Okay, let's do the same experiment with liquids, but by a different way. I have the same cup of water, do you remember it? I have a red dye, maybe blue dye, as you like. I can use the blue one. You can buy like this dye, or you can use potassium permanganate at the lab of your school. Observe with me what will happen when I put a drop or 2 drops of blue dye. What's happening now? Yes, the blue dye is spreading inside the molecules of water, as you see. Can you see? Easily and fast, but is not faster than the molecules of gas. So I can say that diffusion of liquids is higher than the diffusion of solids, as you'll see now. Okay, the dye, the blue dye, is spread everywhere inside the cup of water. I repeat the same one by using a sponge. Is it solid or liquid or gas? The sponge is a solid matter. Okay, when I put this dye on the sponge, I'll take a long period of time to see this dye moving down to the lower part, right? I'll take a long period of time. We can stay a lot minutes to see the result. You have to do this at home and tell me after minutes or after hours you saw the dye in the down part in the sponge. It takes a long period of time. Why? The diffusion of this dye or any dye inside the solid matter move inside very little spaces between its particles. So the diffusion of the dye inside the solid molecules takes longer time than the diffusion of the dye inside the liquids. That takes longer time than the diffusion of this dye or the perfume inside the glass. So we can say the diffusion in gases is much faster than the diffusion of dye in liquids, is much faster than the diffusion of this dye inside the solids. So the speed of diffusion inside gases greater than the speed of diffusion inside liquids, which is greater than the speed of diffusion inside solids. Why? Because here we have very little spaces, here we have moderate spaces between the molecules, here we have very large spaces, so they can diffuse easily and spread easily between them. Okay, what happens if I increase the temperature of the liquid? Focus with me. Which one will be easier, or which diffusion will be faster? When I put a packet of tea inside cold water, or when I put the packet of the tea inside hot water, which one will be faster? Which diffusion will be faster? Of course, inside the hot one. Please do it at home to make sure that diffusion of dyes inside hot fluids is greater than the diffusion of the same dye in the cold fluids. Okay? Also, we can talk about the mass and its effect about the diffusion of states of matter in the next session and complete our lesson, inshallah. Study hard, and if you have any question, write it inside a comment and I can answer. Okay, goodbye, grade 8. See you later.